Here I would like to present the operating principle of the biomass-fired fluidized bed thermal oil heater, designed by DIVI boiler within the DIVI Group as follows. First, I would like to point out some types of fuel that can work effectively for this fired fluidized bed thermal oil heater technology as follows: rice husks, chopped firewood, sawdust, cashew residues, coffee husks, waste veneer, phloem, and so on. In addition, the fluidized bed thermal oil heater can also use fossil fuels such as coal bran imported from Indonesia. At the beginning, the fuel will be put into the conveyor hopper. This hopper is usually located in the fuel warehouse. From here, the fuel will be conveyed by the conveyor belt to the feed throat before being supplied to the furnace of the fired thermal oil heater. At the feed throat, thanks to the fan system, the fuel is moved into the furnace and evenly spread across the grate. In the furnace, plus 2 oxygen and temperature agents, the fuel will perform a continuous combustion process here. Hot smoke will be going up and exchanging heat with the tube containing oil inside and called the thermal oil heater body. Oil-filled tubes in the form of double helical tubes with thermal oil inside will be heated by the heat of fuel combustion in the furnace. Here, most of the heat transfer to the oil will be done by radiant heat exchange. Hot smoke going to the top of the furnace will continue to enter the gap between the 2 spiral tubes and exchange heat convection with the tubes containing oil inside. The smoke stream will go down and up through the narrow gap and exit to the rear heat utilization device. The smoke stream, after heat exchange in the thermal oil heater body, will have a certain amount of excess heat left. So the fluidized bed thermal oil heater system will be arranged with an additional air preheater behind to make full use of this excess heat. The air preheater has a structure where the smoke goes into the tube, the air goes outside the tube. The flow of smoke in the pipe will heat up the air to a temperature of 120 degrees Celsius before being supplied to the furnace for combustion. Bringing up the smoke temperature will help improve the fuel combustion efficiency for the thermal oil heater. And this is the main fan for the combustion process. The wind will be blown into the air preheater. Below the air preheater, there is a hopper that collects the unburnt fuel and is returned to the furnace to burn again, thanks to the Venturi tube system. This will help increase the burnout capacity of the fuel. And this is the channel leading the hot air from the air preheater into the furnace of the fluidized bed thermal oil heater. After the smoke stream is fully utilized for heat, the smoke stream is put into the dust multi-cyclone filtration system to recover most of the ash particles present in the exhaust smoke. The dust multi-cyclone filtration set includes many centrifugal dust settling elements designed according to British standards. The recovered ash falling into the lower hopper will be taken out by means of a rotating valve. The exhaust fan system will help the smoke flow from the furnace to pass through the body of the heat oil thermal oil heater and through the equipment in the rear part of the oil thermal oil heater. The water scrubber tank will help to recover all the ash remaining in the exhaust smoke by spraying water to wash the smoke stream with the Venturi nozzle. Here, 100% of the ash will be completely recovered before being discharged into the environment. Finally, clean smoke is discharged into the environment by a chimney. Next, we will learn about the main oil system of the thermal oil heater. This is the expansion oil tank. This oil tank is placed higher than the oil thermal oil heater body. In case the oil heats up and expands in volume, the expanding oil will be pushed back into this oil bath. When there is a shortage of oil in the system, the oil in this tank will automatically fill in the system. This is a backup oil tank to add to the system when the oil in the expansion tank runs out, or is a place to store the oil when the oil in the expansion tank is full. This is the circulating oil pump assembly. Oil will be injected into the thermal oil heater body to carry out the process of receiving heat from the combustion process. The oil, after being heated, will be put into the part of the equipment that needs to use heat. This is a device we assume has a need for heat. After this part, the oil will be returned to the suction head of the circulating oil pump assembly and continue the heating process. The above is the entire preliminary operating principle of a biomass-fired thermal oil heater, designed, manufactured and installed by DIVI Boiler. This fluidized bed thermal oil heater technology has been transferred to many projects throughout Vietnam. The biomass fluidized thermal oil heater technology designed by DIVI Boiler will help customers absolutely ensure the latest current environmental problems and help customers save at least 30% of fuel and electricity costs compared with current technologies. Best regards to you and your friends. DIVI Group, bringing prosperity to our companions from green energy.